The top that refuses to fall. Spin, torque, and precession. A toy top is set on the table. If it is not moving, it tips over almost at once. But give it a sharp twist, and the same object stands on a point. It leans, circles, wobbles, and somehow refuses to fall. The top is not escaping gravity. Gravity is still pulling down on it. So why does spinning make it so stable? A spinning top has angular momentum. This is the rotational version of momentum. A moving object tends to keep moving in the same direction unless a force changes it. A rotating object tends to keep its axis pointing in the same direction unless a torque changes it. The faster the top spins and the more its mass is distributed away from the axis, the larger its angular momentum becomes. When the top leans, gravity pulls downward on its center of mass. The point of contact with the table supports the bottom. Because these forces do not act along the same line, they create a torque. If the top were not spinning, that torque would simply rotate it downward and it would fall. But when the top is spinning, the torque changes the direction of the angular momentum instead of immediately toppling the top. This produces precession. The top's axis slowly moves around in a circle. It looks as if the top is calmly leaning and orbiting around its point. In reality, gravity is constantly trying to tip it, and the spinning motion converts that tipping effect into sideways turning. This is the part that is often misunderstood. People sometimes say the top stands because spin creates an upward force. It does not. The table provides the upward support. Gravity still pulls the top downward. Spin changes how the top responds to torque. It redirects the falling motion into a slow circular motion of the axis. As friction acts at the point and air resistance slows the rotation, the top loses angular momentum. With less angular momentum, the same gravitational torque has a larger effect. The precession becomes wider and more unstable. Eventually, the wobble grows, the axis drops, and the top falls. The same physics appears in gyroscopes. A spinning wheel can resist changes in its orientation, which is why gyroscopes have been used in navigation instruments, stabilization systems, and spacecraft attitude control. Earth itself also behaves partly like a spinning top. Its axis slowly precesses over thousands of years under gravitational torques from the sun and moon. A spinning top does not stand because gravity has been canceled. It stands because rotation gives direction a kind of memory. Torque tries to pull it down, and spin turns that fall into a graceful circle.